Hello everyone, this is Mike and welcome back to the channel. In this video, we're going to be covering script construction and layout. This will be part 3 and hopefully the last part of my series here on scripting prerequisites or things we should know about PowerShell scripts before we start putting one together. And this should hopefully be the last of the foundational videos that I'm putting together before I start into my Build a Script series, which is where I'm going to be covering building different scripts that do IT admin tasks and in essence writing the script from scratch and explaining each part as I go through. So keep a lookout for that. That'll be part of my Build a Script series coming up. So in this video, where we talk about construction and layout here, we're going to focus on running a script, accepting input, parameter blocks, working with multiple objects, pipeline input, and lastly, doing custom object output. Okay, so let's switch over to the lab environment and begin here. So I am starting off with a blank slate here. So let's say, we actually want to make a PowerShell script out of something here. So we've got nothing to start with. So what I'd basically like to do here, and again, the purpose of this video is not necessarily about what the script actually does. It's all the different elements that go into making a script, okay, and giving it all of the functionality that we might want to take advantage of. All right, so to start off here, let's just say we're going to have a script that does something very basic here. Maybe grabs a service from a particular computer name. Let's say my computer DC1. Okay. So let's say that's what our script is ultimately going to be up to. So I'll do a Control S to save, put this in my data folder, and we'll literally just call it demo1. All right, so that's the name of the script. All right. Now the first part that we're going to be getting into is actually running said script. So what is it, that it's actually going to, to do for us? Will it actually execute? All right. So in order to do that, typically when I am doing script editing, designing, debugging, basically doing script work, I normally work in the ISE, PowerShell's ISE, for doing the actual coding. And then I normally execute the script in a separate PowerShell console. Because odds are that if someone's going to run your script, they're probably going to run it in a console. So I test run it in a console as well. And also by doing this, there's no back and forth of different things that PowerShell remembers as part of a PowerShell session. So when you have the ISE open, you do have a PowerShell session kind of running in the console that's built into the ISE, and opening up a separate PowerShell console creates a separate PowerShell session. So things that are defined in one do not leak into the other. So if you're doing things like variables, PS drives, functions, aliases, PS breakpoints, what's defined in one will not leak into the other, right? So I usually like to edit in one and then run in the other. So I have my script here and I can see there's, demo one right here, and I want to go ahead and run it, okay? Now, if I just type demo1.ps1, you'll notice it doesn't want to run it. And the reason for that is it's not pathed correctly. Right? So when you're running a script, scripts in PowerShell need a full path. Right? So I could type that if I type in C:\data \demo1.ps1, you'll notice the script does execute. Right? Now, what if your path is currently at the folder where the script lives? Well, you could just do dot for referencing the local directory, backslash and demo1.ps1, like so. So you could go ahead and do that. In fact, if you start typing the name of the script out and your path is already where the script is at, just hit tab and it'll add the dot backslash on for you. Okay? So that might save a little bit of typing right there. The other thing we want to watch out for is your script execution policy. So that is something that's automatically configured when you launch a PowerShell session and is set on the computer itself. Okay, so if we run get execution policy, we could see what it currently is on a computer. So most computers out of the box are set to remote signed, meaning that if a script is gotten from another computer, it has to be digitally signed in order to run here. But scripts that I develop here, locally developed on this computer, do not have to be digitally signed to run. Okay, so you could set your signing policy through something called set execution policy, and you can pick different policies to work with here. So the most restrictive one is restricted. So that means no scripts would be allowed to run on this computer. So you could also have an all signed. So that means that all scripts have to be digitally signed in order to be able to run. They have to be digitally signed. The computer has to trust the issuer of the signing certificate when the script was digitally signed, and the script has to match its digital signature. So that means the script cannot have been modified after it was digitally signed. So the default, like I said, on most computers here is remote signed. You could also set to unrestricted, which means all scripts are allowed to run regardless of where they came from, regardless of whether they're digitally signed, but it will still check a digital signature. So it would give you a warning if you're running a signed script and it didn't match its digital signature and so on. And then the last one to know about would be bypass. So bypass runs any script, no checking, no warning, no nothing like that. Okay. So in fact here, I want to set my computer to unrestricted. All right. So we'll go ahead and do that. We'll say A for yes to all. And now if I type get execution policy, I can see that I'm now running unrestricted. All right. Now, in your environment, your computers may very well have this configured on them already, and it might be enforced through your organization. So I could force this through mobile device management. I could force this through group policy. I can force this through SCCM. It might be built in as part of the image deployment. So when an image for a computer gets deployed, that's what happens. Okay, so long story short, even though you can set the execution policy, yours may already be set for you automatically in your organization. So consult your organization admins if that's something you might need to change, modify, play around with, what have you. Okay? So now the next part here, we have this script, and let's say we want it to be a little more useful. Okay. So for instance here, I mean, let's say, like I want it to query the bit service, but maybe I want to allow the person executing the script to pick what computer is asked to get this information from. Okay, so what I don't want is I don't want someone to have to open the script, edit it, put in a different computer, if you wanted to query a different computer name, save it, and then run the script. So that's not how PowerShell's built-in commandlets, functions, and whatnot, that's not how they operate, right? So, like if I want to find a different service, get service has a name parameter. Okay, so we could, specify different things we want to do. If I want to query a different service, I don't go in and edit the code on get service. I don't crack open a DLL, edit the executable code. I use a parameter. So with PowerShell, there are a few different ways of potentially making this happen. So you could do probably one way to be able to do this is we could do read host. So we could put something in a variable here, maybe $PC equals, and then we'll do read host and put a line of text, pick a PC to query, right? Something like that. And then where you want to use that value, we could put it right there, all right? So we'll go ahead and save that. And if I run the script now, there it is. Pick a PC to query. I can put my PC in there, and away we go, all right? So that would allow anybody to put potentially any PC name in there that we wanted to. All right. Now, one thing to remember though, when you're doing something like this, the line of code that gathers the information, it would need to ultimately be stored in the same type of object as the computer name parameter on get service accepts. So get service on its computer name parameter accepts string objects. And again, if we didn't remember that, we could go look at the help on get service and see that computer name takes string objects. So ultimately, the variable that you're presenting to it needs to have string objects. So now when you're doing read host, by default, this is storing string objects. So we don't really have to mess with this at all, right? But let's say you were having someone pick like numbers, like a menu choice, and they picked 1, 2, or 3. That would, if you didn't specify it otherwise, that those numbers would be cast as string objects. And then if your parameter wanted integers, it would mess up. Right? So be aware of that when it comes to read host. It by default puts things in this variable as string objects. Okay, so now another way that we could potentially accept input here is by using out grid view. All right, so if you're not familiar with the out grid view commandlet, this allows me to take output that would normally show up on the screen and put it into like a charting app that you could then analyze the data a little easier with, easier to look at, arrange the columns, what have you. But out grid view can also be a help when you want to collect input as well. So for instance, maybe I don't want people just randomly typing computer names in because they could maybe type in the wrong one. So instead, what I could do is, first of all, let me comment this line out just by putting a pound sign or a hashtag, whatever you want to call that. And let's go and figure out where's a good place to go gather computer names from. And that would be, my opinion, Active Directory, right? You could also use an SCCM collection if you happen to have text files with computer names in them. I mean, there could be all sorts of other areas you could go for computer names, but let's say we're going to go grab stuff out of Active Directory. So I could do something like get AD computer filter star. And that will produce all of the computer objects in your Active Directory domain. Now in mine, if I go ahead and I run this, it's not going to be that special here. It's literally just producing. Let me go. Come on. It's literally just producing. Oh, I have a false one in there as well. Let me go ahead and clean that up. Was doing something else with this lab environment before recording this video, and let's see. So that should clean that up. Okay, so I only have one real computer object in here. Okay, perfect. Now the thing to remember though is, again, you gotta kind of think about it. You're ultimately going to be passing whatever is picked onto here, and this takes string. So you have to make sure that whatever you're grabbing is going to be string. So remember that on a get AD computer, if I pipe this over to get member, that I don't want the AD computer object itself because I cannot pass that to a parameter that accepts string objects. They just don't match up. So computer name needs string. So what values in this object are in string and would be good candidates? So you could do DNS host name or name. It would probably be the two good ones there. All right. Um, so maybe just for this purpose, I'll just use name. All right. So that's what I want to go grab. So I can take this and we'll enumerate the name value. So we could do for each object, and the property I want is the name property. All right. Then we're going to send this to out grid view using output mode single and save the results in a variable. So let's say $PC. We'll use that variable again. All right. So that's it. Let's go ahead and run this. And so there's demo. So it queries Active Directory, finds the computer objects, grabs the name property, displays that here. I can pick it if there was like a list of multiple here and hit OK. And then that value is fed into this variable, and then that's what's used in the body of the script. So in fact, let me go put that dummy computer back in here just so we could see what it's in fact actually up to here. So we'll just throw a dummy client 1 computer in there just to show what this looks like. All right, so we'll go ahead and run this again. And notice now I can pick which computer I want to query. So let's say I pick client 1, that's probably going to error the script out because that computer doesn't exist. So it's thinking on it right now, and there we go. Okay, so it did try to query that computer and it did not exist. So let me run the script again. This time I'll pick DC1 and that query works fine. All right? So that's another way of potentially gathering input. Now, the problem, though, with both of these approaches, read host and out grid view, is the fact that they're relying on the person running the script to supply this. Like a person has to supply these values. And that might not be what you want. If I wanted to run a script, let's say as an automated task or a scheduled task or run it unattended, you can't really feed the values in there, right? If this thing is going to be running in the middle of the night when you're not there, right? So these, while they're easy ways, read host and out grid view of accepting input on a script, they're not the best approaches for your kind of average use of scripts here. So normally what we try to do instead is we try to make the script behave like the parameters on your existing commandlets behave. Okay, so we build parameters into the script. All right, so in order to do that, if I just kind of wipe all this out here except for our line right here, and I don't even want to use that. So we can throw a parameter block in here. So you literally the word param, open and close parenthesis, and you just made a parameter block. And then inside those parentheses, you can put in the variable that you want to represent the information you want to gather. So in this case, I want my script to have a $PC parameter, and then that information can be presented to the computer name parameter on getService inside my script. So when I run this, if I don't supply anything, it's going to error out because it's expecting a value to be there, right? The line in my script, the body of my script is expecting some value to be in there, and if you don't supply it as a parameter, it's not going to work. So now we can bring the script back up, dash PC, notice it even tab completes, And it tab completes in the same case as you see it written in the parameter block. So even though PowerShell's not case sensitive, it does make it look nicer sometimes if you capitalize things here or there. So now if I go and tab complete that, it tab completes out to uppercase. And then put in our computer name and away we go. Okay, so that now works. Now, one problem though that I will talk about here, PC, right? So if you're making a parameter that mimics behavior of other commandlets, try to use the same parameter name to keep people who know how to use PowerShell more fluent in what your script is going to do. All right. So what I mean by that is you take every commandlet that Microsoft produces. If that commandlet can reach out to another computer, the parameter to do it is always computer name. So in my script, probably doesn't make sense to use PC. So I should probably use computer name as well. Okay, so that way I'm mimicking the same behavior that's already present within PowerShell. All right, so do something like that, and then come in here and dash computer name, DC1, and away we go. All right, so that's now operating like a champ. So anybody running the script can use the computer name parameter to specify whatever computer they want to go and contact. Okay, good, bad, or otherwise. But that's what we have there. Now, one thing I may wish to do with the parameter block um, is specify the type of data that I want it to have. So in this case, I know that when I'm collecting this, it's going to be a string object. All right. So that allows me to focus specifically on that. Okay. So save that. So now any data that's supplied in here, maybe you have computer names that are just all numbers, right? So you got to make sure that gets cast as a string because this parameter on getService is expecting a string object. Okay. Okay, so the next one here, working with multiple objects. So with multiple objects, there's a specific way that we probably want to do this. All right. So again, what I'm going to show is not necessarily the only way. It's just what I happen to do. All right. So if you look at, for instance, when I went back and looked at help, um, did I look at help? Yes, I did. Okay. So when I looked at help on a commandlet, remember that like if you look at computer name, see how it's string, and remember these two brackets right here tell me that this parameter accepts multiple strings. Okay, so when you see this after the object, it means it accepts multiple of them. All right. So not every parameter accepts multiple objects. Okay, so in fact, my script, the way I have it right now, does not. Okay, so if I were to try and supply multiple values to it, I would have a problem. I mean, granted, also I'd have a problem as in I don't have more than one computer in here. But let's say I'm doing this and I want to feed it multiple values. See how it doesn't like that. Right? So it's set up to take a one value on the computer name parameter on my script. Now, how do I make it support multiple? Well, in the parameter block where you see string up here, I put the opening and closing bracket like you see in help. So I put that in there. And then in the body of the script, I need this line to run for each object that's in $computer name. All right. So to do that, that's a perfect use of the for each construct. Okay, so we'll throw a for each in here. and maybe $PC and $computer name. Open a script block, and then we'll close the script block down there. Tab our line of code in, and then right here, change that to that. All right. So now, if there's multiple values in there, okay, that gets loaded into here for each. The first value is grabbed, loaded into this variable, and then this script block runs. Then grab the next object out of here, load it in here, and then the script block runs. So if there's only one object in $computer name, this code only runs once. If there's 3 objects in here, this code would run 3 times. Each time a different object is in $PC. So it kind of works through them one at a time. All right? Now, you might be thinking, well, Mike, you just told us not to do $PC, right? It's always $computer name. It's the parameter that's exposed that should be $computer name. Ideally, the person running your script never sees your code, so they have no idea that you're using this variable passed to here. It doesn't matter. Okay, so if you look at when I'm running, oh, I should have saved that. Control S, save that. So ideally, when I'm running the script, it's still computer name. All right, so notice that runs, and if I give it another one, it's going to error out, don't get me wrong, but it is running it. So it is trying to do both values. So there's the one that worked, and then here's the one that's erroring out. Okay, so that was different than what we had up here where it just bailed altogether. Okay, so that allows me to have a parameter accept multiple values. Okay. Now, what if though I wanted to pipe those values in? Okay. So actually, no. Before I do that, there's one thing I should also probably do to this parameter here. And basically, like the script has an Achilles heel that someone needs to supply a computer name in order to make it work, right? If you don't do that, it doesn't work. So you could, in your parameter block here, make computer name a mandatory parameter. So someone always has to supply a value. So in order to do that, you can use the parameter element like so. And then in the argument list that goes with parameter, you can literally just put the word mandatory in there. All right. So there's lots of different arguments that could go in parameter. We'll put a couple more in here before everything is said and done. But that's one way to accomplish this. Okay. Now, if you see other tutorials, demos, instructions, whatever, a lot of cases they do mandatory equals true. You don't actually have to do that. By using the word mandatory, you're turning something on so it's true already. So by putting mandatory equals true, it's like a double, I don't know, it's like a double positive. All right. So just put the word mandatory and away we go. So now what happens if I try to run demo, notice how it's prompting me for at least one computer name. So I could supply that carriage return on an empty line, and then it goes ahead and runs. All right. So forcing someone to supply a value to computer name. If you supply the value on your own, you do not see that. Okay. So that's probably a good thing to do. Now, with this though, my parameter block is starting to get a little carried away. So you could actually take the parameter block, and what most people do is they split each parameter on multiple lines, because ultimately I'm only going to have one parameter in here, so it's not too bad. But understand you can split it onto different lines here. Okay. Okay. So the next part here, piping data in. So for instance, like let's say I had the name of a computer in as a string object. And remember, when you put things in quotes and hit carriage return, PowerShell will cast that as a string. So if I pipe that over to get member, we could see string object. All right. So now I take that string and pipe it over to my script. And it's not accepting it at all. See how it's still prompting for, hey, you need to supply a computer name. So it's not seeing this string as input to this script. So remember that a commandlet or your script, because your script is basically acting as a commandlet here, in order for it to accept pipeline data, you have to tell it what parameter on the script the pipeline data goes to. And I did not do any of that. Okay, so can we fix this? Absolutely. Okay, so the first one here, and again, the terms I'm going to be using here when it comes to pipeline, I have a video talking about pipeline parameter binding. It's in my PowerShell Basics playlist if you go look for it there. And that covers how data is passed from the pipeline over to a commandlet. And in this case, our script, which is basically behaving like a commandlet, it has parameters on it. So if you're not familiar with how PowerShell works with this, the by value and the by property name system, head over to that video. Look for pipeline parameter binding. Okay, so now with PowerShell, data is passed over one of two ways, by value or by property name. And so in your parameter element, you can declare which parameters accept pipeline data and how they're going to accept it. Right? So if you wanted to, you could go ahead and add something in here. So I'll put in here, come on, type. There you go. The value from pipeline. So just putting that word in there, and again, this in a lot of cases, a lot of people when they do this in scripts put equal true. You don't have to do that. So just putting the word in there is good enough. Right? So what that does is that says that this parameter that you have accepts pipeline input by value. I know the word by value is not there, but that's what this is doing. Right? And so that's the first step. And then the second is in the body of your script, you need another looping element. So with pipeline data, when you have pipeline data coming in, you have three separate looping sections that you can put in your script. You can have a begin block, a begin script block, which is code that's processed before we look at the pipeline data. You have a process block, which will loop once for each object that's in the pipeline. So in this case, I want to take basically the body of my script and loop this for each object that I'm piping in. And then finally, you can have an end script block, and that would be code you want to run after the pipeline data has been processed. Right? Now, of these three sections, the only one that is required is the process block. Right? So you don't need begin, you don't need end. They're optional. Right? So, I mean, use them if you need them, don't get me wrong, but they're not required to accept pipeline input. Okay, so now at this stage, I can save this and then come back in here and rerun this and notice the pipeline data is now accepted. Right? Um, and in fact, I could pipe in multiple strings, right? And it will work through both of them. Right? So you can have that. Right? Now, you may be thinking though, well, why did you need a loop here? You already had for each. Well, the for each loop is really for when someone supplies multiple values directly on the parameter. Okay, so that's what the for each covers. And then the process loop is covering multiple objects being piped in. So by putting a for each inside of a process, you're covering both scenarios. If someone pipes in multiple objects from the pipeline or someone manually types in multiple objects directly on the parameter, right? Like I did earlier here, right? So that's multiple objects directly on the parameter. And again, notice it still runs, right? So, so that's adding pipeline support. Now, the way that I added it was by value. Okay, so that way if there's string objects in the pipeline, they are sent over to this parameter that accepts string objects. Now, I could also add in a value from pipeline by property name. And that would, I'm looking to make sure I spelled this correctly. Sometimes it's hard to talk and type at the same time. That would then add support for the by property name system. So what that means is any object in the pipeline, string or whatever else, as long as it has a computer name property on it, the values from computer name for the object in the pipeline will be sent over to the computer name parameter here. All right? So that's using the by property name system if we wanted to do that. All right. Okay, so with that now being the case, we can then start focusing on maybe output. Okay, so for instance, I'm just letting the script do whatever the default output is for the commandlet that we're ultimately running here. So get service. Now the problem, not necessarily a problem, but the limitation of that, by letting the commandlets output on their own, you're getting whatever objects they're creating. So, like, let's say I'm, getting getting a service controller or something like that. All right. So now, what if though I wanted to see the name of the computer that was also included here, that was queried, and maybe I wanted to see some bit of information about that computer, maybe like the operating system it was running, right? So that now has to come from somewhere else. Get service doesn't have that information, right? So I could do something like this. Don't get me wrong. Let's do get AD computer. And in this case, the identity of the computer, the identity of the computer is going to be $PC. And let's grab, let's see. Let's see, what do I want? Properties, operating system. Okay, so I think that's what I want. Let's see. So let's go ahead and run this. And okay, so here's the get service output, and here's the Active Directory output. And I told it to go, by default, the Active Directory commandlets only output a few properties from each object, and operating system's not one of them. So I told it to kind of include that in the list. So that's why I did that here. So that'll add that on. If you wanted to grab every property, you could just do properties star. But in this case, this is the one I wanted. So that kind of limits the query to Active Directory. A little more efficient, if you will. A little more easier to use. All right. So, so let's say, I just let this output on its own, and it's not really the easiest to read in the world, right? So I literally want maybe like, these pieces of information, and I want the name of the computer and the operating system. So those are the things that I want, and I don't want to see anything else, right? So that's where potentially you can output your own object if you wanted to, all right? So to do this, first of all, you can take the queries that are run and store them in variables. So this would be $S for service, let's say, and then $AD for the Active Directory query. Okay, so I'm now grabbing that information. All right. Now the next part is we're going to put together an object for output. So I'm going to make a property table that I'm just going to call $props, and I'm going to make a hash table. So each name value pair that I put in the hash table is going to represent one of the properties. All right. So for instance, let's say I want my object that I'm outputting to be have a computer name property. I can do computer name, and I'm typing them nicely. And then that would equal, let's see, $AD dot, let's do the fancy one. We'll do DNS host name. So I'm grabbing this property right here. Okay, so that's going to be my computer name. All right, so that's the first name value pair. So then I just do a carriage return. When you're doing multiple, it's easier to line them up just one vertically under the other. So computer name, what did I want? Operating system. So I'll just call that OS, and then we'll do equal, and that was $AD dot operating system. Then the next property we wanted, let's say we'll call this service name. Oops. Service name. And then that would be $S dot name. So remember that was the service info. We'll do another carriage return. What did we want? Service name, and then status equals and $S dot status. Heck, while we're here, maybe we'll do start type. We'll throw another one in here just for hoo-ha's. $S dot start type. So that'll get me that info. And let's see here. And we wanted display name. Something like that. Okay. So now I have that property table created here. And then I'm going to make an object with that property table. So I'm going to do new object, and the type of the object is just a PS object, and the property $props. Okay. So we'll just go ahead and do that. And in fact, that should actually be out at this level. There we go. Save this, and let's see what happens. And what do you know? It worked. Okay. Now, it didn't. One of the things that I don't particularly like about the output is if you notice the order of the properties in my hash table and the order of them out in the console here, it's not the same. So unless you tell it otherwise, PowerShell doesn't feel that the hash table has to be ordered the way you wrote it. So what you do is you throw the ordered element in front of it to make it display in that exact order. All right. So notice now if I run this, they're in the exact order that I had specified. All right. And in fact, now I should probably fix this. Why do I keep hitting cap lock when I want tab? I should probably fix these. So again, they're nice and lined up. Like so. All right. So that's everything is nice and nice. All right. So anyway, now one of the things though, especially if you think you're going to be outputting multiple objects, is I never really just run this on its own here. I normally capture it in a variable. And then if I don't want to do anything with it, I can literally just do write output $obj, something like that. So I capture in a variable, and then I immediately write that variable out to the pipeline. All right. So again, it works. And if you were doing multiple, you'd have multiple objects outputting. If you didn't want the output to be like right now, it's doing a list. If you wanted a table, you could take the output here and just format it to send it over to format table. If that's what you wanted, and you can get your table output if you liked. I don't typically like to do that because format table totally scrambles your data. It's not true PowerShell objects anymore. So normally I'll just let PowerShell do whatever it's going to do output wise as its default, especially when you're working with multiple objects. And PowerShell does have some rules on that. If the custom object you are making is 4 properties or less, PowerShell would output it as a table. If it's 5 properties or more, PowerShell outputs it as a list. Okay, so a list meaning the properties, the properties are on the left over here, and then the values are on the right. With a table, you have one, header row, and then each object is just a row underneath that. All right. Now, so you might be thinking again, why did I save to a variable just to write the variable out? Just let new object write directly out to the pipeline. And the reason why I chose to do it that way is because I might want to mess with the object before I send it out to the pipeline. All right. So, I mean, not all the time, but, let's say you're going to be doing some other things with this, you might want to do that. That might be something um, that might be of interest here. Okay. Um, so depending on what you want to do with it. You could go add some code between one and the other here. So for instance, before I do this, let me show kind of a before here. So if I take my output and pipe it to get member, notice that's the kind of object it is. So what I could do is I could take that object and call the PS object property, call the type names property underneath that, call the insert method underneath it, and then on the object, I want to put in my own type. So maybe this will be chassis, TAC dot service. I should make it look nice. Service object. Something like that. Close the method. And cool. So let's go ahead and save that. And now, when you first run the script, it doesn't look like anything. It's still just the regular output. But check out if I pipe this to get member. Hey, now looks like my own object, which could be handy if you want to do other things with other scripts that you might write that work with that kind of object. All right, so instead of just having everything kick out a PS custom object, you can have it kick out your own kind of object, which could be handy again for making things support for other scripts, other functions, other commandlets that you might have authored. All right. So that's kind of looking at doing some custom output there. Right, so I apologize on those videos on the longer side, but that's basically looking at everything that we might want to do from beginning to end. Actually, before I could do on my end deck here, let's just bring this back up so everybody can see everything here. Where we added in parameters, we typed the parameter, it made the parameter accept multiple values, added pipeline support, made a parameter mandatory, gathered information, stored it in variables to make a custom output. So a lot of different things here that you build around your script. And again, this was not a complex script, right? This is basically what I'm doing right here. That's the whole heart of the script. I'm gathering a service from a computer. So all the rest of this is, how am I piping data in? How do I want the output to look? How do I want to work with multiple objects? That's, adding all of those other things in, right? So that'll wrap it up for this video. If you like the content, please consider liking and subscribing. If you have any comments, feel free to drop them down below in the comments section. And so like I said in the intro, this will wrap up my series here on scripting prereqs, and be on the lookout coming down the road for my Build a Script series where I take different admin tasks that we might want to do and build the script using these techniques from beginning to end. All right, so be on the lookout for those. So again, thank you for watching, and please consider liking and subscribing and keeping an eye out for the next video. So have a good one, everyone.